Hi, Bobcats. In this section, we're going to take a look at spontaneity, which is really pretty much what it says. It's a chemical reaction that takes place just all by itself. It doesn't need anything else to make it happen. It's just spontaneous. And the connection between that and entropy. Entropy is the thermodynamics term for disorder or randomness. Our main objective is to define entropy. Spontaneous reactions are those that occur without any sort of outside push. I took photographs of these two glasses. One of them contains ice, the other contains melted ice, also known as liquid water. If the temperature is above 0 degrees C, it is spontaneous for this reaction to go in the forward direction. Ice becomes liquid water. But if the temperature is below 0 degrees C, such as in a freezer, it's spontaneous for this reaction to go in the reverse direction. So spontaneity can change depending on the conditions of the reaction, but something that's spontaneous just happens all by itself. Entropy is the thermodynamics quantity that describes randomness or disorder. If we compare these two diagrams on this slide, they have very different degrees of randomness. The diagram on the left shows a crystal of sodium chloride that is surrounded by water molecules. The diagram on the right has some sodium ions and some chloride ions that are now surrounded by water molecules or dissolved up into the water. The fact that the things are mixed up makes the diagram on the right have a higher amount of entropy, and the fact that we've got the sodium chloride and the water separated make the system on the left have a lower degree of entropy. Entropy and spontaneity are connected in that an increase in the entropy of the universe is the driving force for a spontaneous reaction. Another way of saying that in the language of thermodynamics is that delta S, the change in entropy for the universe, is positive for a spontaneous process. This clicker question asks us to consider a process that has delta S of the universe positive or greater than 0 at 25 degrees C. So what can we conclude? What do we know about this process? Well, the fact that delta S of the universe is positive tells us that this is a spontaneous process. So the best answer for this question is answer D, that it's spontaneous at 25 degrees C. Exothermic and endothermic are indicated by the sign of Q or delta H. So if it's exothermic, Q is negative, and if it is endothermic, Q is positive. If we are doing reactions at constant pressure, Q is equal to delta H. So sometimes you'll see this as delta H being negative or delta H being positive. Our objective is to define entropy. Entropy uses the symbol S, and it is a measure in thermodynamics of randomness. The more random or mixed up something is, the greater the entropy. And we also saw that if delta S of the universe is positive or greater than 0, then the reaction associated with it is spontaneous.